Okay, right. So today's agenda or the topic that we are going to cover today is files and data streams, right? Data streams, it's called a stream because data flows like a stream. So that's why they call it data streams. So what's available in C Sharp? How do we use it? You can work with text files, you can work with binary files, you can work with XML files like we did last week, if you remember, though we didn't look into it, but I give you an example of XML files. So today, if time permits, I'll kind of go through it. But as I said, it is not that tough. So why do we use files? Like what's the need? Why do we need to use it? So if you can remember, till date we've been using arrays and lists, and those are the two dynamic structures we've used, the list and the array, which is of a fixed size. We've been using variables, we've been using class variables, local variables, block variables, but all these are created in memory when you run the code. And then once the code finishes execution, poops, all gone, everything, nothing is saved, right? So all changes that you make, maybe you're saying, oh, I make changes and I'm putting it in a list, nothing stays, because all that we've done till now, all data types, data structures, whatever we've done till now, they're all volatile in nature. They get created in memory when you compile and run your code, and then once it's done, they're gone. And that's not how we can kind of survive in the world, right? You know what I mean? Like if things just go away wherever, then how do you come back? And we all know that. You've been using storage for years now, and you kind of save your songs and save your files, or whether they're paper files or whether they are digital files, you have everything saved. Save the images that you want, pictures, it's all full of saving. So we do need to save so that we can retrieve it back. And how can we save? We can save in files if we like, because they are permanent storage in the sense, unless you delete them, you can save data in databases. So these 2 weeks, 11 and 12, basically I'll work on files today, and then I'll work on databases next week, right? And again, I must confess, and I hope you understand, that there is so much to do that I can't do everything like completely. So I kind of introduce you to it, give you as much as I can in an example I do. And then whenever you need it, you can always go back. At least you know that you've done it. So for example, we did some classes last week. I haven't finished with them, but again, I can't put a lot into it because of time. I'll come back to it in maybe week 13, because the other section is a week behind you. So you have kind of an extra week. So I'll do classes again when I hit week 13. Okay, they only have 2 left. So I have to do files and databases. And I'll assign you your last assignment, which will be a combination of classes and files, right? So it will be a multi-form project. So you haven't done multi-form, kind of. You've done splash screens and about forms, but that's not to do with data, right? So we'll create a multi-form project. You will have to know how to kind of transfer data from one to the other, using files to store your data and so on. So I'll go through the assignment with you today, but I won't post it because I still have to do it with my other section. So I have to give it together and then take it back together. Or if you like, I can give it to your section, but I mean, you will get the same time. I'll be giving a kind of a week for it, almost a week for it. And you'll have to work in pairs. You'll work in pairs. So it will have more marks attached to it because it's a full-fledged bigger assignment. So maybe I'm thinking 15% is what I'll attach to it. Okay. All assignments that you've done till date, except 5, everything is marked and it's up on Blackboard. So 1, 2, 3, 4, and your midterm, everything is marked. So I'm now going to start working on marking 5, right? It takes a little time. It takes almost 15, 20 minutes per student. So I'll start marking it today, and hopefully in another week, I'll be done marking 5 also. So any assignment that you've done completely from scratch, like 4 and 5 were from scratch, I'll give it 10%. Anything that was small is 5%. And then this last assignment is 15%. That's how it is going. Okay, that's how it sits. So everything till assignment 4 is marked. So double check you have marks if you were present in class. That's the biggest thing, because those were in-class assignments. If you were present in class and submitted it on time, I'll mark it. That's how it is working. Okay. So as I said, there is one last assignment to go. Please see that you have a partner for it. I'm not taking individual assignments. You can do it with your own class fellow if you like, or you can do it from another section. Really doesn't matter to me, but it has to be done in pairs, right? So as I said, I just have to wait for it because my other section is a week behind. So next Tuesday it will be up. Okay, so I finish this off, and then next Tuesday I'll post it, and you will have the weekend to do it. So it will be back. I will have it back around Monday. So I'll give you almost a week for it. So keep ready. Just that will be your last assignment. That's what we are aiming on. Okay. Okay, so as I said, I'll go through the power slides today because there is so much to do and I can do it in one example. But if you understand what the concept is, so what is a file? A file is a permanent data structure. It's a data structure, you save data in it. A file has a name. There are different kind of files. We'll work with text files. So all you do is save text in the file, right? You could kind of create a structure or a record structure for yourself. So if you were saving information about an employee, for example, you would maybe keep his name, ID, salary, joining date in a line, and then you would go and save the second record in the second line and so on. Binary files are also available. Binary files are available, and there are classes and methods that you use to work with binary files also. So I'm going to not do them practically, but I'll talk about it as I go through the slides. Okay, they have their own classes and own methods. So when you work with the file, basically you have to open the file. When you open a file, you open it either for reading or writing, or both read and write. So those are its modes, right? So you may only read from a file, you may write to a file, or you may read and write both from a file. Once you open it, and you could, as I said, you could do these three things. When you read from a file, you'll have to say how I want to read it, because remember, it's just flat file, it's just text file. So you will have to manipulate in your code as to how am I reading. Do I have data 1 piece per line? Do I have data 3 pieces per line? What does each piece represent? Is it the name of the employee, the number of the employee, and so on? Everything has to be kind of configured and understood by the programmer, because you'll be saving to the file and reading from the file. When you open a file for writing, you could erase the previous contents if you like and just start fresh, or you could append data to the file. So depending upon, do you want to open it in the append mode or only the write mode? The difference is write. If the file exists, it will remove everything and start fresh. If you say append, it will leave the contents and then append. At the end, it will add records. So that's writing. And read write means you should be able to read from it and also write to it. That's how you work with the file, right? So files are of a permanent nature, of course, have a name, have a structure that you define in your program, that is you manipulate it, otherwise they're just flat files. And then you know how to read and write from files. Okay. And at the end of the execution, the files are there for all time to come. They are permanent storage, unless of course you delete them, but they are permanent storage. So any changes that you make will reflect in the files. So it's all your job, how to open them, how to manipulate them. Okay. You could be hard coding the name of the file in your code, which of course I wouldn't like. You could ask the name of the file to open or read or work with from the user. And for that, I'll show you how to use open file dialogues and save file dialogues today. Like when you open it in Windows, when you try to open a file, you can go to a particular folder, you can select a particular file. All you're seeing is an open file dialog, right? You're seeing a window through which you can select a file. I'll show you how to do that in C# also. We have components, they're called open file and save file dialogues, and I'll show you how to use them. Okay, but coding the name of a file, hard coding the name of a file in a program, I don't think it works. Then every time you have to change the file you want to work with, you'll have to go into the code and change it. But it's an option. You can always say, I'll always be reading from this file and I'll always be writing to this file. Files can be created wherever. There are certain exceptions that are thrown if a directory doesn't exist, if a file doesn't exist, if there is some problem in reading, writing, everything, all methods are available. You need to know how to use these methods and also need to know how to handle the exceptions thrown by these methods. As long as you know that, you're good. Okay. So having said that, as I said, I'll quickly go through the PowerPoint slides so that you know what's in the slides, so that when you do your assignment, you know where to look back if you want. But of course, this is not the end. There are so many resources up on the internet that you may not even look back at it. But it will kind of give me assurance that I went through everything with you in files, because I can't cover it in an example. Okay. So let's look what is available. So basically, as I said, I'll do text files today, but you have text files and you also have binary files, and I'll develop an application. We'll work on something that we did before. If you have it with you, you can use that. If you don't have it, it's available on Blackboard, right? So I've put under weekly learning, start files. I've put something called files.zip. It's the last in your list. It comes under files. Get it, unzip it, and I'll be working on it. So you've done that example before. We'll do it with files today. So we'll talk about what's a text file and binary file. Then I'll talk about these classes: file stream, stream writer, binary reader, and binary writer, right? So we'll talk about these classes because you'll need them. So for text files, you use a stream reader object to read, and you use a stream writer object to write. For binary files, you use the binary reader object to read and binary writer object to write. The file stream class itself basically is to create a path, right? You can say this is where I want to open my file. So to create a file object. So we'll kind of look at all these classes very quickly. So what do we need to use, or what do we need to include in the namespace that we have to include when we use files is the system.io. So system.io classes will be used, and you will just have a using statement up in your code. We need that. We can't work without it. So you can either qualify your class names wherever you use it, which is, I think, too much typing, or we just say using. So system.io classes is what we will work with. And you can kind of categorize them into three. Classes that deal with directories, files, and paths, right? So we'll look at what they mean. So here are the common methods. So if you want to check if a path exists, do you want to create a new directory? Do you want to delete a directory? Do you want to delete a directory recursively? That means everything inside the directory first, and then the directory is deleted. So for example, notice how here a particular hard-coded file name has been given, and the @ in front of a string in C means take it as its face value, whatever I say. Otherwise, remember, backslash is a special character. If you don't put this @, then it will give you a syntax error saying, what's this \C? I don't know. We know \n, we know \t, and so on, but there's no \C. So when you use @ the symbol @ in front of a string, it just says this is literally what you have to take it. Don't assume any other meaning. So a path has been given, so a directory has been created. It is saying look on the C drive under C#2015 for a folder called files. And an example is of the class directory. An example is if this directory does not exist, create it. Right? So this is how you use the method of the directory class. And all the directory class, if you can kind of make it, is a static class. Notice how I'm using exist, the method exists with the name of the class. So as I said, I wouldn't like you to hard code the names of these paths in your code, but there is an option. It's always a good idea to take it from the user. Which directory do you want to go to, or which file do you want to work with? And you'll say, oh, asking for input, but not in the way, not the user doesn't put in text. The user can choose or select from the files that are available on his or her drive, local drive. Okay. So here is an example of a class called directory. So if you wanted to check if a directory exists, there is a method called exists, and this is the path. That's what is the path. That's what you've defined here. And if it does not exist, is just creating a new directory, right? So there are methods that are available. So as I said, I can't cover all of them, but at least I'll kind of work with them. Here is the file class. So you want to work with the file, and the file is directory plus products.txt. So directory is what I had already mentioned on the previous slide, and it is saying it is looking for a file called products.txt. So before you start working with the file, if you want to check, does it exist? You can use the exists method of the file class. So you're saying, does it exist? If it exists, I want to delete it, for example. So before I start, I want to delete if the file already exists. So again, you have methods, you have the exists method, you have the delete method, the copy method, and the source method with files. So you have methods with directories, you have methods with files, and then you have methods with path, right? And then I'll show you how to use the file stream class. Okay, so before you start working on a file, check whether it exists or not. I mean, if it doesn't exist, you can't read from a file that doesn't exist. Okay, though an exception will be thrown if you try to read from a file doesn't exist, but you should go step by step. Does it exist? Yes, it exists. Now try to read from it. So if you wanted to do that, that's how you will do it. But if you're asking the user to select a file name, then the chances are the file exists. You know what I mean? The user is choosing a file, so it will always exist for reading, but you can always check. Right, so the difference between a text file and a binary file, as I was mentioning, a text file is flat text. You can open it in a text editor and you can make head and tail out of it. So for example, the first one, notice how is visible. You can read it. It has a code, it has the name of a book, and then it has a price. That's what it has. And it has been separated by these these lines in between. So how you save data is entirely up to you. And it is important that how you save data is the same way that you read data. So maybe you are separating the data by commas, maybe you are separating the data by tabs, any character. But when you read from the file, you should know. The same file, when it is opened, if it is a file which is a binary file, then of course there are characters in the file that you can't read in a text editor. So text file is a flat text file that is readable by human eyes. I can open it in a text editor and I can read it, right? That's what a text file is. On the other hand, binary file is a file that is manipulated by the system. Everything is saved in binary and kind of manipulated it for us. We don't bother how it is saved. We just read and write from it as we would like, but we have to be careful. Are we reading a byte? Are we reading a character? Are we reading a string? Everything has to be done by the programmer. So both files are available. I'll deal with text files because they're much easier, but binary files are also available in C#. Right, so what is a text file? A text file that contains characters. The fields in each record are typically delimited by special characters like tab or pipe characters, and the records are typically delimited by new line. So you as a programmer will decide how will I save my data. So as I said, if I wanted to save data about a student, for example, and I wanted to save his or her ID, student number, or maybe program, then I'll say, okay, this is how I'll save it. I'll create a record structure, and one per line I'll save the student number. Maybe I'll put a comma in between, maybe I'll put a tab, maybe I'll put the pipe character, then I'll save the name of the student, and then I'll save the program name. When I read from it, definitely I have to know this is how I saved it. So when I read from it, I'll say read the whole line and then kind of split it on your delimiters. So whether it's comma or pipe character. And then each piece of information, I should know what it means. The first one is the student number, the second one is the student name, and the third one is the maybe the program name or whatever. So it's your job, okay? The programmer's job to work with it. A binary file, on the other hand, can contain a variety of data. So text file is plain text, strings, nothing else. Everything is a string. Numbers are string too. So when you read it, you'll have to convert it and use it. Whereas in a binary file, you can work with various data types. That's why I said if you wanted to read a byte or a character or a number, you have to know what you saved and how you read it. But the onus is always on the programmer. How the files are saved, what is their structure, what is their name, you have to read it in the same order so that you know that's how I saved it and that's how I read it. Okay, so what are the streams that are available by the help of which I can read and write and all that data into these files? There are two streams. One stream is the text stream to read text data, and one is the binary stream to read binary data. So you have a stream reader for reading text files. You have a stream writer to write text files. You have a binary reader to read binary files and a binary writer to write data into binary files. So these classes are available. Right, so here are your classes. So these are the classes that I'll work with today, not with the binary ones. File stream I won't need because I'm going to show you another way of doing it, but it's not a big deal at all. So it provides access to input and output files. So you're basically going to open a file and say, oh, open this file in the read mode, open this file in the read write mode, open this file in the append mode. That's what happens with file stream, which you can also do with stream readers. I'll show you with stream readers how you can do it. But that's what a file stream is. It's just a class that allows you to access input and output files, and you say in which mode do I want to open the file, and you have an additional parameter too with this object. You can also say whether I want to share this file with others, like so sharing can also be done. So the same file can be maybe read at two times by two different programs. So these are the second and the third class definitely I'll work on today. I'll try to show you file stream also today, though I'm using a different approach, but I'll show you how to use file stream also today. Right, so here, notice when you create an object, a file stream object, notice how it says, give me the path, give me the mode in which you want to open, the access, and then anything in square brackets is optional. So basically you have to give a path and you have to give a mode. Okay, and the mode, if you don't give a mode, then I think by default it assumes a particular mode. I can't remember. The access is default, the mode has to be given. So here are the modes in which you can open. In the append mode, you can create a file, you can create a new file. The difference between create and create new is when you create a file, if the file already exists, it will wash it off. All contents will be lost. Whereas create new says it should not exist at all. I want to create a new one. Okay. Open means to open it. Open or create means if it is existing, open it. If it does not exist, create a new file. And truncate means remove everything from the file context. So I'll show you how to use it. Okay. These are the file mode enumerations. They're constants. Therefore, they're called enumerations. Remember, enumerations, they are constant values. So you can say, for example, new file stream, you can give a path and you can say comma append. So what's happening? The file that you've given in the path, the file name that you've given in the path is being opened in the append mode. So when you write to that file, the data will be added to the end. That's what the append mode is. Okay. So each mode has a certain property, like that's how it works. That's what it means. Okay. How do you access the file? So notice how this is optional, but how do you access the file? So if you don't see anything, I think there is a particular default. I can't remember what it is. So you can open a file for reading, you can open a file for writing, or you can open a file both for reading and writing. So that's how the access. What do you want to do with the file? Do you only want to open it in the read mode? Do you want to open it in the write mode, or do you want to open it both in read and write mode? In the file share enumeration, none means I'm not going to share the file. That's the default. So a file is not shared if you don't mention anything. It's none by default. If you say the file sharing is reading, then though two programs together can read from the same file. That's what sharing means. If you say it's read write, more than one program or two or three programs can together read and write on the same file. And if you say that the file share is write, two or more programs can together write on the same file. That's what it means by sharing. And how do you close a file stream? Definitely, we always want to close a file stream. Never leave file streams open is through the close method. Okay, so we'll use it. I'll show you how to do it. It's not a big deal. See, here is an example. So I want to create a file for writing. I want to create a file for writing. So a path has been given. So this is the file I'm going to use. So the path is mentioned here. And then notice a file stream object is created and it will be opened in the create mode, right? So create means create. So if it exists, overwrite it. If it doesn't exist, create it. And it will be opened in the write mode. Notice how I use enumerations. I give the name of the class and dot the name of the enumerated constant. Like in Java, you say math dot whatever, or you use the color class, color dot blue. Same kind of concept, right? Same kind of concept. So that's how you will open a file in the write mode. And the create simply says that if it exists, overwrite it. And if it doesn't exist, create it. Create an empty file. That's what the create does. So each of this enumeration has a use. When do I open it in create? When do I open it in read? When do I open it? When do I say create new? And when do I say append? Everything has to be done. So definitely if you're creating, you will be using the write access. You can't say create a file for reading, like doesn't make sense. See, so which goes with what? Logically they make sense, but whenever you use it, you have to say if I'm opening a file in the write mode, I can create it, I can append to it, you can add data to it, but only in write. You can't append data to a file if you're saying open it in the read mode. Doesn't make sense. So which goes with what combination is logical. This is creating for reading. So notice how this file will be opened in the open mode and it is for reading. You open a file for reading. You don't open a file for writing. You create a file when you want to write, or you do a create new. So the combination is logical, right? You can't say create a file and the mode, the access is file access dot read. Doesn't make sense. You don't create files for reading. You open files for reading. So which enumeration constant goes with what? You should kind of make sense. So append will go with write. Create will go with write. Create new will go with write. Open will go with read. Open or create can go both with read and write. And truncate really doesn't matter. Truncate just means remove contents. Right? So how do you open it? What mode do you use? What access do you use? There has to be a logical connection between the two. Right? So here are just examples how you would open a file for writing purpose and how you would open a file for reading purpose. That's how you open it, right? So as I said, I won't hard code the name of the file in my code. I can show it to you. It's not a big job, but I prefer that the user select the file from existing files. If you're going to read from a file, it must already exist. If you're going to write to a file, may or may not exist. If you're going to append to a file, must exist. I mean, if you're adding data, but if it doesn't exist, it just adds new records. And here are the exceptions that we'll have to work with. We'll have to work with IO exceptions, directory not found when you're using the directory class, file not found when you're using the file class, end of stream. You're reading from a file and you've reached the end of the file and you're still trying to read. Of course, it will throw an exception, right? If you can't find a file, it will throw an exception. If you can't find a directory, it will throw an exception. And then there is a group of IO exceptions that we will work with. So these are the exception classes that I will work with today. So you should know how to handle them. So you have opened a file for reading and without even checking, you're just reading from it. How can that happen? You have to stop somewhere. The file ends somewhere. So you have to say, while the file has not finished or while there is more in the file, read from the file. If you forget to do your while loop and you keep on reading, of course, you're going to come to the end of the file. And then if you try to read and there is nothing in the file, it will throw a end of stream exception. Okay, so you have to take care of all this. So we'll use try catches to take care of it, but we'll also do defensive programming. We'll write the while loop. We'll know how we have to do it, but we'll still put it in try catch just in case. Okay, so you just catch these exceptions. So we'll learn how to do that today. So for example, a particular directory has been given, a file path has been created, a file stream object has been created with null. Notice how. If the file is not found, it will say the file is not found. If the directory is not found, it will say directory is not found. And what is it trying to do? It is trying to open this file in the open mode, right? It's trying to open it in the open mode. So I don't know. I can't remember. I think it's read. By default, it is read if you don't give the third parameter. So what are you doing? You're trying to open a file in the read mode and maybe the directory doesn't exist or maybe the file doesn't exist. So you'll say, how do I check? Put it in try catch. Use the required exceptions and there it is. It will print out and say, I can't open the file because it doesn't exist. So it's always a good idea to check before you start reading or writing to the file. So if you're trying to open a file and it doesn't exist, it could be because the directory doesn't exist or it could be because the path, the file doesn't exist. So you should be catching these exceptions before you start working with the file. And I'm safe because I'll show a file dialog and the user is selecting something, so can't go wrong. You know what I mean by when you select something, it is there, only then you are selecting it, but it's available. And here is the IO exception. So the IO exception could be anything. So what they have done is they've basically shown the message. Something else occurred. It was not a directory problem. It was not a file problem. Maybe it was something else, an operating system problem. Who knows? But file couldn't be opened for whatever reason. So you'll give a message on the screen. Okay. So notice how they are in a certain order. So file not found, directory not found, and then the generic one, the last one is the IO exception. Also notice that I'll always be using finally now with my try catch blocks in files. Why? Because it is a good idea to always close your files irrespective of whether you were able to do something with it or whether an error occurred. So either way, right? Either way, you should always close your files. Successfully open, everything done, you want to close it. You'll say, but I haven't done anything with the file. Of course, I mean, this is incomplete. It says code that uses the file stream to read and write. So you've done everything. But when you leave, you should always close your files. So finally says this will always happen. Whether you are coming out of the try, that means everything is done, or whether a catch was executed and something went wrong and you have to close your streams. So you use the close method to close your streams, but see, before you close it, you always check, oh, was it open even, right? Maybe it never got opened and there was an error. So you always check, is it open? And then you close it. So I'll start using finally blocks today because finally says always do this, even after try or even after catch. So I'll do that. I'll do this today in my example. Now, how do I write to a file? So I've opened a file in the write mode. Now it's done. Its file is ready for writing, but how do I write it? Right? So write, you create a stream writer object with that stream object that you created, right? You create a stream writer object, and then you can write the data. You can write line the data. So you can put a data and then the pointer just stays there. You can do a write line. It writes the data and goes to the next line. That's the difference between write and write line. Like your print and printlns. Same concept, okay? So writes the data to the output stream. And what is the output stream? The stream. And what is the stream? A stream that you've already opened using that file, the file, what was the name? File stream class. Okay, so it's already open now. All you're doing is now just getting it ready for writing. So write line data says write the data to the output stream and appends a line terminator, usually a carriage return and a line feed. I'm not sure if you know, but there is a difference between the Windows operating system and say Linux, for example, right? How it saves the return character when you press return, when you press the enter key on your keyboard. In Windows operating system, two characters are saved: a carriage return and a line feed. Whereas in for Linux, for example, only one is saved, or Unix. Generally saying Unix, only one character is saved for enter. So keep in mind that a file that is created on a Windows machine may behave differently when it is used for input on a non-Windows machine, because how it is saved, it is saving characters. So when you press the return key or when you say write line, it saves two characters for the enter key, a carriage return and a line feed. Whereas on Unix operating systems, definitely I know Unix, I'm not sure about Mac. On the Unix operating systems, it only saves one character for the line. When you say write line, it just saves the line feed, doesn't save the carriage return. So text files that are created on a Windows machine may behave differently. When you try to read from it, here you are saving two characters for the write line, there you save one. So when you try to read from it on another operating system, it may behave differently. So therefore, files are not kind of interchangeable in the sense because of this problem. And it exists. It has always existed. I'm not sure about Mac. Maybe Mac users can tell me how it works. And the close method just closes it. Closes the stream writer object. So I'll work with this for sure today. So here is a simple example. I create a new writer object called text out. I go new stream writer, and notice instead of creating this separately as a separate statement, I've created it right here. So I'm opening a file that is mentioned in my path, which is a variable, in the create mode and opening it for write. So create this file, it says. And what am I doing? I'm picking up everything in my products list. I'm assuming it is a list, and I'm writing to the file. Notice how I'm writing: text out.write, put the code, and then put a separator. Write the description, put a separator. And notice in the third one, I've said a write line and put the price. So how is it saving? Per record, you have the code. Remember from last week, we were doing a product class and each product had a code, description, and price. So I'm saving the code, I'm saving the description, I'm saving the price, and then I go to a new line. So one record per line is how it is being saved. So you have to decide how you save it, because you are the one who is going to read from the file. The programmer has to read from the same file, right? So here is an example of how you create a stream writer object. And notice how I've created, I could do this separately, but I've kind of put it in the same, and I've said, okay, open this file, whatever your path is defined as, open it in the create mode. So the file will get created if it does not exist. And if it exists, if it is empty, good. If it is not empty, previous contents are lost. That's what happens, okay? And it will open it in the write mode. So if you're in the write mode, you can use your write statements. You can use your write methods. You can't use your write methods in the read mode, okay? Now, so that was for writing. Simple, write and write line. Two methods are available. All you have to do is create a stream writer object, and there you are. And the stream writer object wants what from you? The file that you want to work with, okay? On the other hand, if you want to read from a file, you use the stream reader object or the stream reader class. You create a stream reader object. Again, the stream says which file do you want to read from, and here are the methods. Peek. The peek method says, is it there? Do you have more? So this is what you will use. So while or if there is something in my file to read. So peek says returns the next available character in the input stream without advancing. So it checks, it just peeks to see, oh, do you have something more? So if the peek value, it returns -1 if there are no more characters. So if it is -1, that means you are done. The file has finished. You don't want to read from it. So you will use the peek method to say till where do I keep reading. Read reads the next character. Read line reads the next line. Here is where reading is different. Read line will try to recognize what? That combination of two characters, carriage return 13 and 10, carriage return and line feed. In ASCII, it's 13 and 10. If you look up your ASCII table, carriage return and line feed are 13 and 10. So that's what it looks for. Read to end reads the complete file, absolutely the whole file. Everything from top to bottom, doesn't matter what it is. It reads the data from the current position to the end of the stream and returns it as a big string. Remember, everything in a text file is a string, nothing else. It's all string. You manipulate it. And close will close the stream reader object and the associated file. It does both. It closes the stream reader object and it also closes the file stream object. Here is an example. So I have opened this file for reading and I've opened it in the open or create mode. So if it already exists, it's open. If it doesn't exist, then just create a new one, create a new empty one. So it's kind of useless, but that's what it does. Notice what I'm doing. So I'm saying read from the file where there is more to read. Notice text in dot peak is not equal to -1. What is the text in? Your stream reader. So you're basically saying while there is more contents in the file read, get a row at a time. I've called it row. You could call it anything. So use read line. Then you split it on your, remember how you saved your data? You had your code, then you had your pipe, description, pipe, and then the data, and then the price of the book. So when you read it, it reads the whole record at a time. Read line, picks it up. Now you have to split it. So you split it and automatically it goes, the split method will put it into an array. And then now you pick up one at a time. Code is column 0, that is the first element of the array. Description is the second element of the array. And the third element, remember, it is a string. So if you want to use it as a decimal, convert it into a decimal and put it into the price. And then add this product to your list. So you're reading from a file. So it's your job as a programmer. So you have to know how data is saved in my file so that when you read it, you exactly know how to read it. That's how you have to do it exactly, because what are files? You have to exactly know how to work with files. Okay. And then when everything is done, you will close your files. So I haven't done anything in try catches right now. This is just showing you simple methods, but definitely read line may throw an exception. So I'll put it in a try catch block as depending upon what the method is throwing. Can't remember all methods and what exceptions they are throwing. When I start typing, I can always bring my mouse over it and say, oh, this is the exception it throws, and we'll catch this exception. That's how we'll work with it. Okay. So a class has been given which works with a text file, and this is actually the same that you did, the XML file that you did with your last example. They have kind of worked it with the text file. So I won't go through it because it's not a big deal. I'll be using something like this today, right? So this is actually the same example you did last week. Instead of an XML file, they've used a text file. So I could actually take this code and replace it in my example last week, and it will exactly work the same way, right? So there is a level of abstraction, basically, which you don't have to bother about. So this is exactly the same code. Now, binary objects, I'm not going to do it. I'm not going to, just because I don't think I have time, but binary files, you can work with binary files in all languages, not only in C#, in all languages. So when you want to work with the binary file, definitely you use a different class. So to write, you use binary writer. To read, you use binary reader. To write the data, you simply, there is only one method, write data. But this data could be a character, could be text, could be a decimal number, could be an integer number, and it could be anything. But all you're doing is write. But how you read it is important. So here is an example, same kind of stuff. You create an object, open a particular file in the create mode in write. You are picking up everything from your list of products and you're writing it. Write. Simple, nothing else. It's just a write. There are no write lines, nothing. Binary data just means binary data. When you read from it, that's where the importance will be. How do you read from it now? So you have to exactly know. I wrote a code, then I saved a description, and then I saved a decimal number. So to read it, what will you do? Definitely to read a string, you will say read string. To read an integer, you will say read int32. To read a decimal, you will use read decimal. So when you read from a binary file, you have to know as a programmer, how am I reading it? Again, the interpretation is entirely up to you. You have to know how I saved it. So if you wrote your code, description, price, you have to read it as code string, description string, and price as decimal or integer, whatever it is. So for us, it is decimal. Okay, so here are the methods. You open a stream reader and you read from it. So for the same file that you've just created using binary, notice what I'm doing. Read string will get me code. Read string will get me description. And read decimal will get me price. So I'm reading again from the file while I'm not reached the end. Notice I'm using peek character. You're reading one character and saying, is there something more? Peeking means just English word peeking. Peeking means looking ahead. And read it and put it in your own list. So see, file manipulation is entirely the job of the programmer. How you save is how you read. You have to know it. it's kind of hard-coded in the sense that you exactly have to know how I saved it to be sure that you read it in the correct order. If you don't, if you mess up, if you said read string, read decimal, read string, of course it's going to mess up, right? So you're reading the code as a string, you're reading the description as a decimal number, and you're reading the decimal number as a string. So it will entirely mess up. It's entirely up to you how you do it. So here is an example of how you work with the binary file. And it's again the same file that we did last week as a binary file. Same program. All you have to do is take this code and replace your product db.class from last week. One, try the XML file, which we already did. Try it with the text file. It will work the same way. Try it with the binary file. It will work the same way, right? Because all you do with the file is reading and writing. So again, if time permits, I'll copy paste and show you that it works. So here is, they've just given an example that the user maintains a list of student scores and all that. I mean, I'm not using that example today, but it's available in the book. Okay, so there it is. So on the higher level, on the abstraction level, you should know how to open a file in the read or the write mode, create new, and so on using the file stream class. 1, 2, you should be able to read from a file using a stream reader object, and you should be able to write to a file using the stream writer object. Today, I'm going to use the stream reader and the stream writer objects classes with you. I'm not using the file stream just because I'm using a different concept. I'm going to show a dialog box and let the user choose from it. And then if the file, of course, if the user is choosing, the file will exist for reading. And if the user says, oh, this is the new file I want to create, then it already exists. But as I said, it's not rocket science. I can maybe replace it just to show you how the file stream works. Okay, so with me. So as I said, you may have to revert back and kind of look at these slides, or of course, as I said, there are so many resources when you do your last assignment, which I'll post. I can't post it before Tuesday. It's ready, but I can't post it just because my other section, as I was mentioning, is a week behind. So they will do files next week with me. Once it is posted, you will have 6 days to complete it. So I'm not saying a week because I'll post it on Tuesday and I'll try to take it back on a Monday so that I can mark it on Tuesdays and Wednesdays. I'm short of time too now, guys. Remember, last 2 weeks.
So sorry, it'll be posted next Tuesday.
Next Tuesday,
okay,
yeah.
So and
just so that everybody has it at the same time.
Yeah, and you're advising.
Because till now you've been taking an assignment ahead because it was an in class and it didn't matter. But this is a final 15% pair assignment, right? So look for a partner, work with the partner, and do it in pairs. I'm not taking individual assignment, guys. I'm not marking it. 1, I'm short of time. I'm in week 13, right? 2, it is a bigger assignment. You're going to work on a multi-forms assignment that is going to use files and also going to use classes. So it's a bigger assignment and it has bigger marks. It's 15%. Okay, so I will post it. I mean, if you really want, I mean, I don't know how your other assignments are working. I'm not sure. Like, are you? I mean, I'm sure you're time pressed for assignments always. So, but I'm trying to be fair this time, just because it's a bigger take-home assignment. I want to give it to the same time to both my sections. So I just have to wait for you. Hopefully, you won't forget everything. But anyway, so it will be posted. An announcement will be posted to that effect. You will have the assignment. The only thing you have to do, maybe all you can do before it is maybe just partner up with somebody. Right, that's all you have to do, and I'll give you 5-6 days to do it. So Monday night I'll post it, kind of, or Tuesday morning. Monday, most probably I'll post it on Monday because Tuesday morning I see them. Once they are done, everybody can do it, and then it will be due by Sunday midnight or Monday midnight, whatever works. Monday will also work for me. I'll mark it Tuesdays and Wednesdays. I have to mark too, so I'm kind of thinking about myself too. Okay, so it will be paired. You can look for a partner. If you don't have a partner, email me. So I'll just group you with anybody then. That's how it works. Okay. If you can't find somebody, say, Anju, I can't find somebody. So if I have 2 people approaching me, I'll just put them together. So it's up to you. If you want to look for somebody with whom you like to work, go ahead and do it. Okay. So you have enough people in your class. And again, you don't have to stick to your own section. You can choose somebody from the other section too. Doesn't matter to me. Okay. Okay. Now that we have kind of browsed through these PowerPoint slides, I would like to do an example with you. So for students who have come in late or were sleeping early morning, this example is available on Blackboard. So this is an example that you did last I don't know, maybe a couple of weeks back with me. I've just added a few, not much, a little things to it. I've just added 2 components to it. So if you don't want to use my file, open up your previous example, and then I've just added 2 components here. That's all I've done, which are coming from Toolbox. Right? So this was an example. As per se, it runs like this is how it was working. So I haven't added anything because I'm going to do it. Okay, so this comes up. Guys, these are small things. Centered screen, form should not be resizable, do not maximize it. These are all, this should go without saying. But if I don't say it, half of you don't do it. So now I have to kind of make it a point that I put it in every assignment. But these are in your common instructions. But I think you don't pay attention to the common instructions when you do an assignment. There are common instructions on Blackboard, which I said have to always to be followed, that I don't have to say all inputs must have shorthand access keys. Form should be centered, cannot be maximized, cannot be resized. Please rename your forms, your applications, your controls. Follow one convention consistently in your project, whatever you like. I don't know, people tend to forget and you lose marks because that's how it is. If keyboard access keys are not available, it's not user-friendly. So I say user-friendly, I assume you will look at the common instructions, but I found out in assignment 4 that no, I can't assume anything. You know what? A programmer, I mean, these are assignments, good, I understand, but take onus. Always try to create a product, whether it is an assignment or whether it is real life, always try to create a project professionally. Think this is a professional thing I'm doing. So forms are big, contents are small, headings are not centered. There are spelling errors on the form. Like, what impression are you giving? Nothing. Like the interface is poor, right? So whatever you create, see that you pay attention to it. So after 4 and 5, I said, oh my God, I have to maybe spell it out. And so I spelled it out in assignment 5 again. Should be centered, cannot be maximized, cannot be resized. Please see it has keyboard access keys. Tab must be in the proper order. These are small things. They just go without saying. They don't have to be put in every assignment, though they are there. They're still there on Blackboard. But everybody is in a hurry, right? So whatever. But anyway, I try to mark fairly. I asked for a context menu and I'm getting a normal menu. I'm saying, uh-oh, there is a difference. A common menu doesn't have to be associated with the form. A context menu has to be. You create a context menu, but you don't associate it with the form, it doesn't show up. So I'm saying what to do now. So I kind of am lenient when I'm marking in the sense that I'm saying maybe, but you know what? You have to be professional. So this last assignment that is coming to me, whether it's for 15 or 20, doesn't matter. It has to be perfect. Okay, so that's why pair-wise, more time and do it good, do it well. And I'll mark it strictly now. Till now, I've been very lenient. You've been seeing I've been very lenient. I've said, okay, you missed it, don't do it next time, kind of stuff. I've taken a, because it's not rocket science. You can do it. You just are careless, right? Which you shouldn't be. Professionals cannot be careless. So keep that in mind. Okay, so this is what we had done before. Oh, that means I removed my list. Anyway, so this is gone now. I had some flavors. So let me add some flavors. I'm just adding a juice flavor or whatever. But you know what? I'm not that bad. I can go vanilla nut. So I go vanilla nut and I add it. I can do it. There it gets added to my list. I can do something like corner blend. Just remembering from what we did last week. And I can add it. And it gets added, right? I can add another one. What else? I forget now. Okay, I can delete something. Or I can count how many flavors do I have. There is your count. It says you have 2 flavors. Looks good. You can delete it. And remember in delete, I did add this. You could delete it. You could give the name right here. How we had that extra. You can give the name right here, which who would like to give, and you can select. But anyway, and you can go delete and it will remove it if everything has been spelled right. So everything is working. What is not working is this. So you're adding flavors, you're deleting flavors, you're updating your list. Everything, you're doing everything. But if I close it and I run it again, oh, I have to talk about form closing also today. I again run, gone. No changes were kept. And that's logic. Like there's nothing, it's logical. Why? Because you were using, I forget now, a list. You're using a combo box. The combo box has that dynamic items collection. And in the items collection, it's just dynamic. It's just a list, right? So what happens is, so to begin with, I had some flavors there, but I don't have them here. So I see an empty list. But what happens is it gets populated, and then whatever you do, you're working with that. You're only working here temporarily with the list, right? So it's just a temporary list. So when the program finishes execution, it is a volatile data structure. Volatile means created in memory, dead when the program stops execution. And it's gone. Everything is gone. Now, if this is a small example, but if you were going, for example, me, if I'm saving the marks of my 80 plus students today, and tomorrow I come back and I want to make a change in somebody's marks and all my marks are gone, havoc, right? I'll panic. I'll say, oh my God, all that work gone. That can't happen. That's not what I want to do. So definitely you need a permanent storage structure to work with. And that's what is a file. 1, files, and 2, data structures. When your data is kind of manageable, not too large, you use files. And databases, when you have millions and trillions of records, then that's what you use databases. So you have to use files if you want to store your data as a permanent storage, right? And that's what we are going to learn today. Okay, that's what we are going to learn today. So what am I going to do? This is what I'm going to do, and this is what I've done. So if you've picked it up from Blackboard, you will notice I've added 2 components here, the open file dialog, right? Open file dialog is one of them, and save file dialog. And I've just left their names as such. But if you come to the open file dialog, it has a few properties here. Look at the properties. It has a name. It says, can I add the extension and so on? What is the default extension? What I'm kind of interested in is check path exists. And it says, it's like anything else. See, when you open a Windows Explorer and you kind of say, I'm looking for a file, don't you just go and kind of look for it? And if I want to open it, you go in here and just open it, right? So this, what you're seeing here is a file dialog. What you're looking at here is a file dialog. When you save a file, you do the same thing. So for example, I open up Word, I create a new file, and I do a Control S, right? And it says where do you want to save it or whatever. I just save browse or something. What I'm doing here is, come on. What I'm doing here is this is a save file dialog. So you're saying, oh, I want to save it in my documents, in my backups, and wherever. So this is a save file dialog. Okay, so that's what comes up. Notice what happens is, notice how it says save as here on the top, and you can do a save or a cancel. When you open a file for reading, if I want to open a file for reading, I say file and I say open, and I say, okay, which file do you want to open for reading? So if I'm trying to open a file that doesn't exist here, I mean, I don't have an option because I have to select from something, and that's exactly what I mean. When you select for something, it definitely exists. But if you try to open a file that does not exist, so if you're working on a command line, for example, and if you're trying to open a file that doesn't exist, it will tell you it doesn't exist. So this is when you open a file and it gives you something like this, and you kind of say, open this file, for example. This is just a file that I recently used, my marking scheme, for example, for assignment 5, and I open it, it will open up. But if I wasn't able to open it, then of course the dialog box will say, okay, what's happening? Where is that file? Okay, so these are called dialog boxes, right? These are called dialog boxes. These are called open file dialog boxes and save file dialog boxes. So when you try to open, you will have an open and a cancel. When you try to save, you will have the buttons save and cancel. That's what it means. So here, notice the properties of this open file dialog says, when you try to open a file, and it will check if the file exists. And if the file doesn't exist, it will tell you, a message comes up automatically, file does not exist. It will check if the path exists, I mean the whole directory exists. And if it doesn't exist, it will say it doesn't exist. So if you want to keep them as true, good. But if I don't want the open file dialog to kind of take care of my exceptions, I want my code to take care of it. Here I'll say, you don't check it, I'll do it myself. So you could change these properties from true to false. So we'll do it first, and then I'll show you how you can, what's the difference, right? So there are a few properties here that you can read about and see that you know what you're working with. Similarly, save file dialog. When you try to save a file, notice how it says, check file exists is false. It doesn't check whether it exists or doesn't exist. It just overwrites it in a save, though it says, is it okay to overwrite? So here, see how this has false. Check file exists is false. Create a prompt is false. Create a prompt means it will not create any prompt. It will just overwrite the file. So again, these properties of your dialog boxes are important and they kind of play a role. And I'll show you how they play a role. So that you say, oh, this is why it is asking me, does the file exist? Oh, this is why it is overwriting it. All is linked to these properties. Okay. So all I've done is in this new project, I've added 2 components to my component tray. And also notice under file, I've added 2 more. You had print selected flavors, you had print all flavors in your old old assignment, old project, class project. I've added these 2. Open file to get coffee flavors, save coffee flavors in file or to file, whatever you would like to, right? I mean, if you would like to kind of go, oops, my mistake. That's what happens. If you want to say, I want to kind of change this instead of in file, I want to say to file. But remember, once the name is given, then you, and whatever you make a change, it doesn't happen. Right, so you can change it here. So open file to get coffee flavors, save coffee flavors to file. So this is what I'm going to do. So these 2 are new on Blackboard. If you are going to use your old project, just add these 2 menu items. So I added 2 menu items and I added 2 components in my component tray because I need them. I need to use them. Okay, that's what I did. So notice I have in this project I was using the other the default another convention. So each name it says open file. You say, but here it's a different name. When I created it, I called it open file and I changed the name afterwards. Open file to get coffee flavors. So once you give a name and you press enter, that's the name that goes here. If you change it afterwards, then that change is not reflected. You'll say, what if I want to change it? Just go here and change it if you want. But I thought that was too big a name. Open file to get coffee flavors was too big a name. Open file is a good enough name. Similarly here, save files. I said save coffee flavors, I think when I began, and then I changed my mind and I said, oh, I want to call it save coffee flavors to file, for example. So if you change it here, and all you have to do is if you want to change it here, you come here and then whatever you want to do, you can just kind of like just write it. But any changes you make here now will not go there, which is okay. Like if you want to, but those are 2 big names. The print selected I did last week. So it's simply called, or 2 weeks before, it's called print selected flavors and print all flavors. So whatever you type here automatically becomes the name of your control, only for menu items, nothing else, not for buttons, not for text boxes, only for menu items. But it saves me time. I don't have to do it. So for this menu alone, I went with this convention so that I didn't have to change it and put TSMIs or put it in the front. So as long as you follow one consistent naming convention in your project, I'm okay, right? Whether you want to use the 3-lettered and 4-lettered words before the name, TSMI, BTNs, RDOs, but the right ones, of course. Don't make up your own, okay? Radio buttons is RDO, not RAD, okay? So you can use that. 2, you can put the name of the control at the end of the control, like here. Or you can put the complete name in the beginning of the control, whatever you like. But follow one convention, please, throughout your project. Don't mix and match. Variables, camel case. Methods, Pascal case. Constants, Pascal case. How difficult is it to follow conventions? Okay, so now my job. My job is this. I would like to do something in my open file. So double click on it. Oh, I think I already had it. I think that's also already given to you. Empty stubs, of course. But I think I already double clicked on it. So I haven't changed anything. The rest of the program remains the same. I just made it a little neater in the remove. I mean, I just kind of just made it neater. When I was doing it in class, I did it a different way. I checked whether it was available or not. It was just a different order. I just made it neater because you say, if it is -1 and it is not there, let me give the message first and then check for the others. I just changed this sequence a little from what we did last time, but it's not different. It works the same way. It's just more neater. It makes more sense to my head. Comments are always there. Notice I always have a comment, and commenting will be required in your last assignment. I'm looking for good commenting. Your name, date, purpose at the head of each file or whatever you create, plus every method, every event handler, every method that you create has an explanatory comment in the beginning. Detailed one. What does the method do? That's what its functionality comment is. And then, of course, you can add comments wherever you like. For example, here I've said no selection was made, user has input, user has selected, and so on and so forth, right? And of course, if don't give me empty methods, please. If by any chance you double click on a method and you create something empty, or you want to remove, please remove it. Please remove it. Okay, because I don't want to see empty code. And it's not difficult. All you do is you go to your design and remove it from your events. Mine are empty because I'm going to use them, right? But I don't want to see. You're clicking on labels, you leave the code alone. You leave it for me. It's so untidy. All you have to do is this. You go back to your design. We know an easy way now. Go to wherever you have messed up. For example, you messed up here. Go to its properties, go to its events, and just delete it from wherever you want to delete it from here. Right? I don't have anything, but just delete it and it will go from your code too. How long does that take? Not even a minute. So like, be a professional programmer is what I'm trying to bring home. Okay, so let's go back to our form. Okay, so what do I want to do? An open file tool strip menu item. So this open file menu item allows the user to select a file for reading. That's what it does. Okay, so I'm using a dialog box. So the dialog box was called open file dialog box. Remember, it's in my component tray. I will show that dialog box to the user and I'll tell the user to choose a file wherever. Now, by default, I mean, you can place your file anywhere you like on your local machine. It really doesn't matter. You just have to go and choose it. But by default, if I was using a hard-coded string path and I just give a file name, by default, it looks for a file in your current project in the debug folder. There is where it goes and looks for the file. That's where it assumes your data file will go. So if no path is given, nothing is given, it will go and look. By default, it will go and look into your debug folder. You'll say, where is that? If you open your project in your Windows Explorer, and let me go to the right one now. So projects, Wednesday, files, collections. So inside it, it's called collections. There is your bin folder and here is your debug folder. If you place a file here, a text file here, an XML file here, whatever, if you place a file here and in your program you hard code your file name, path is equal to the file name, it will by default go and look here. That's its default path. So if I place it here, then every time it will go and look here. If I don't want to place it here and it could be anywhere on your local machine, then of course you go and look for it. So the open file dialog is kind of just letting you open a file from anywhere on your local machine. But of course, when you give your project to me, please ensure that your data file is in your project so that I'm not creating it, right? For now, today I have nothing. So I'm going to create a file right here. I'm going to create a text file right here in this folder. It will automatically pick it up if I hard code it, and I'll show you how to hard code it. So this is what I'm going to do. Go to your debug folder. You could do it from your Visual Studio also. It really doesn't matter. You can do it from here also, except that it doesn't show it, and we'll have to say show all files somewhere. There should be a show all files. Collapse all, show all files. If you go on show all files, the bin folder will also come up here. Okay, you can do this. Usually it doesn't come up in the Solution Explorer. Okay, so if you go and click on this show all files, everything will come up, right? Inside this bin folder is a debug folder. Oh, I already have a coffees.txt. I didn't see it here. Did I see a coffees? Oh, I have it. Okay, I've already created it. Okay, so here now you can always select it, go a right click. Oh, select it, go right click, and you can say add. And you can add. Oh, that's all it can add. I should be able to add a new file. The add only has Azure API app client. That's strange. I see a rename, a delete, a copy, a cut. And the add only has this option. Under debug, I can't do anything else. Include in project, no, doesn't make sense. The new item is not, the add doesn't have any options. That's strange. You have an open folder in File Explorer. I could go there and do it, but I thought I could have an add and I should be able to add a text file right from here. I didn't bother to do it here. I did it from outside, but that's strange. So all I did was I added a coffees.txt here, and all it has are those flavors, right? So I added it. So create a coffees.txt, call it whatever you like. You don't have to give it the extension .text. I'm kind of just sticking it because it's a text file. So create a file coffees.txt or call it whatever you like. I'm going to use coffees. You can use whatever you like. Create a file. It's a text file. All I've done in this text file is I've placed the names of my coffee flavors on different lines. That's all I've done. That's all I have in this file. Right? That's all I have in this file. And save it. It's just a text file. So this is what I'm going to do. I'm going to read my coffee flavors from this file. Any changes that I make, I delete a flavor, I add new flavors, whatever I do, I'll keep a record of it. Did I change anything in my flavors? If yes, before I exit the program, or if you say I want to save it midway, I'll save it back to the file. So every time the program runs, it is picking up its data from this file, and every time the program exiting, it's also putting back everything in this file. So your data is always updated, always updated. Okay, so this is a text file that I created. By default, as I said, you can put it wherever you like. But if you would like to give a path, you just want to mention the file name coffees.txt as a hard-coded file name in your data. By default, it goes and looks here. That's what it does. Right? So I could just put it and it will automatically look for it. But I'll use a different approach altogether so that I don't even rely on anything. So what does this event handler do? It shows a file dialog. Right? It shows a file dialog and prompts the user to select a file. That's what a file dialog does, right? So it shows an open file dialog. You can say open file dialog. It's called an open file dialog. You're opening a file, right? So it's called an open file dialog. So there is an open file, there is a save file. They are very similar. All they're different is in their properties. So you could use one for the other as long as you know how to set the properties. I just like to use them separately because their name makes sense. Open file dialog, save file dialog. But it's the same dialog box, except it will have a different title, but so I stick to what I need instead of saying, oh, I can use one for the other. No. If you want to open a file, use the open file dialog. If you want to save a file, use the save file dialog. Okay, so it will show a file dialog to the user and it will prompt the user to select a file. Now, in its easiest sense, let me show you what happens, okay? Just to show you what happens, and then I'll kind of, remember you had that open file dialog? Just say a show. I think, I'm not sure. Yeah, it's a show dialog. I'll just show you how it works. I've just written this for now, nothing else, right? I could set its default properties. I'll only select text files. By default, I'll go to a particular directory. I can do all that. It has all those properties. I'll do it. But I want to show you what happens. So if you now start your code and click on File, Open, see, this is what comes up. This is called an open file dialog. So what do you have? You have the option of browsing and just picking up the file that you want to pick, right? So if I wanted to pick this file, I can select it. And then I'll say open and the file gets open. So this is the file I want to work with. That's what the open file dialog is for. So instead of hard coding the name of the file, so I won't need to use the file stream class, but I can show you how to use it. But I mean, my directory will always exist. My file will always exist because I'm choosing it, right? Selecting it. And the only problem that can occur is maybe while I'm opening it in the read mode to read, I get an exception, which I can always catch in my stream reader also, right? So that's why I don't need to open that or use that class. But yeah, that's what an open file dialog is for your information. Okay, so notice how it has open here, how it has open here. So if you try to open something, so let's try to open something that doesn't exist, ABC. It doesn't exist, okay? And try to open, see what comes up. It says, and where is this dialog box coming from? Remember, it had a property which was saying check if file exists, and it was true. That's where it is coming from, right? It says ABC, file not find. Check the file path name and try again. So if I don't want to see this message, I'll say, oh, you don't bother about it. I can take care of it myself. Let my code take care of it. I can do that. So this is coming from there. So that's the true property of check file exists. That's what it is. Right? I can't give a directory here because otherwise it will say directory doesn't exist, but it's saying file not found. So, and notice how when I opened the open file dialog, do you notice where it went? it went, I mean, you can ignore the rest, but notice it went into the debug folder inside the bin. That's where it goes by default to look for files. So that's what I was saying. That's its default path. So if I don't use an open file dialog, I just give a file name, it will try and go and look there. So if your file is placed there, it can be opened. Otherwise, it will say otherwise, of course, it will throw an exception and I'll say something like file does not exist in my code. So this is your file dialog box for your information. Okay. And this is coming up because the open file dialog has a property which says check file exists and it is set to true. So if it is set to true, it will say it does not exist. Okay. So I do an okay. So that's what a file dialog is for your information. So it says open here, not save. It says open here. It has open here, not save. So that's the difference between open and save. The open one will say open. The save one will say save. Okay. And if you cancel it, then nothing happens. So you have to check, did the user cancel it or did the user open a file? Maybe if the user says cancel, you want to just shut off. Application terminates. User doesn't want to work, is not opening a file, can do nothing. Stop my application. Okay. So you check what's going on. Okay, do you understand what the open file dialog is? Once you know that, now I'm going to do a few things here. So before I open it or show it, I'm going to set some of its properties just so that it's neater, not a big deal at all. Okay, I'm going to need, I'm going to need a dialog result variable because the user has two options, open or cancel. So I need to know that. So I need some, I need some local variables. You know what? Let's take a break because this won't happen in 1 minute. Let's take a break, come back, and then do these two things. I'm at 9:15 already. Okay, because when I see people moving in their seats or looking at their watches, I know something is wrong. Okay, so we'll take a break, 20 minutes, come back, and then we'll complete this. Okay? Okay, let's stop this going.